This is chapter 5.8, completing the square. You use completing the square for quadratics. The word quad, or the portion of the word quadratic quad, comes from Latin and it means square. So in completing the square, we're going to use that idea of a square. We're going to start with number 39. Okay, x squared plus 6x equals -3. Since it's a quadratic, we know we can form a square, so we're going to go ahead and draw a square. We know that we've got to have an x squared, so that means this is going to be x times x, which will give us x squared. We're going to have 4 other parts. You're familiar with this table method. And we need to have 6x, and I'm going to highlight it right here. We need to have 6x from here and here. So in order to get 6x, we need to have 3x here and 3x here. Well, how do we get that? We go plus 3 and plus 3. So x times x is x squared, x times 3 is 3x, 3 times x is 3x. That leaves this amount here, 3 times 3 is 9. So now we have a perfect square. Okay, so now we have given x squared plus 6x. So that part's all good. We've got x squared and 6x, but we don't have anything in the original problem for 9. So we're going to put plus 0 because nothing's there. So we can put plus 0 equals -3. Then I have to say to myself, how do I get from 0 to 9? Well, I have to add 9. If I add 9 to the left, I have to add 9 to the right. And so I end up with x squared plus 6x plus 9, equaling -3 and 9, which is positive 6. Well, x squared plus 6 plus 9 is these dimensions, x plus 3 times x plus 3, equaling 6. X plus 3 times x plus 3 is x plus 3 squared, equaling 6. Well, I want to get x plus 3 isolated, so I'm going to go ahead and take the square root. Let's change colors because now I'm doing an inverse operation. I'm going to take the square root of x plus 3 squared to get just x plus 3. Whatever I do to one side, I have to do to the other side, so I'm going to take the square root of 6. And we're going to end up with x plus 3. Now, whenever I take the square root of a number, it could be plus or minus. There can be a positive, meaning -3 times -3 is 9. And positive 3 times positive 3 is 9. So it can be plus, minus. You remember this hopefully from the quadratic equation. So it's going to equal plus or minus the square root of 6. Now, finally, I got to get x isolated, so I'm going to subtract 3 from both sides. And I'm going to end up with, x equaling -3, there's your -3, plus or minus the square root of 6. This can often be faster than the quadratic equation. So that's one of the benefits of completing the squares. It's often faster than the quadratic equation. All right, number 40 is x squared minus 10x equaling 4. And what I want you to do is I want you to try what we did in 39, see if you can complete 40. If you have any problems, go back and look at what you did in 39. And then once you're finished, turn the recording on and see how you did. All right, for x squared minus 10x equals 4, you had your x times x, which is x squared. You needed to get -10x, so it would have been minus 5x here. And then that would give you x and -5, because x times -5 is -5x, and then x and -5 this way, -5x, -5 times x is -5x. And then finally, in the last part of the table, -5 times -5 is 25. All right, you need, this was the problem you had, x squared minus 10x. There was nothing in the third term, so I put a 0, equaling 4. You need this 0 to be 25, so you add 25 to both sides. So you end up with x squared minus 10x plus 25 equals 29. 4 and 5, 25 is 29. This is now a perfect square trinomial, x squared minus 10x plus 25. So that is, whatever these dimensions are, x minus 5 times x minus 5. So x minus 5 times x minus 5 equals 29. x minus 5 times x minus 5 can be rewritten x minus 5 squared equals 29. You take the square root of both sides to get rid of that square, and you're left with x minus 5 equaling, now there's where you have to be careful. If you take the square root of 29, it has to be plus or minus the square root of 29. Then you're going to add 5 to both sides to isolate the x, so it ends up being x equals 5 plus or minus the square root of 29. Again, one of the benefits of completing the square when you have quadratics is that it's a lot faster. And let me come up here to this title and go ahead and write completing the square quadratics. It's a lot faster usually using the quadratic formula. Okay, our next problem is going to be number 41, x squared plus 6x minus 6. You know you're going to have your square. You know there's going to be some dimensions. Here and here are going to be x, and this has to be x squared. Go ahead and see if you can complete the square using this idea, and then turn the recording back on and check your work. Okay, number 41, you had x squared, that's your x times x. And then this 6x, you had to have, this plus 6x, you had to have equal values here. So 3x and 3x gives you 6x. And then that would mean your dimensions had to be x times x for x squared. And x times 3 is 3x, and this is also 3 because x times 3 is 3x. Then that leaves the last quadrant of your square. 3 times 3 is 9. So here's what you started with. X squared plus 6x minus 6 equals 0. You needed to get to a value of 9, because this is a perfect square trinomial where it equals 9, so you need to get to x squared plus 6x plus 9. So to get from minus 6 to plus 9, you say negative 6 plus what number will equal 9? If you don't know that number, you can just add 6 to both sides, and then you'll have the number that you're looking for left, and 9 and 6 is 15. So you have to add 15 to both sides. So it's x squared plus 6x, negative 6 and 15 is 9. There's your perfect square trinomial. And then 0 plus 15, which was what you had here, is also going to be 15. This perfect square trinomial, x squared plus 6x plus 9, is the dimensions x plus 3 times x plus 3, equaling 15. We can write x plus 3 times x plus 3, x plus 3 squared. To get rid of a square, you take the square root, which leaves you with x plus 3. You have to then take the square root of the right side, which is 15. When you do that, you end up with a plus or minus the square root of 15. And so you're still not quite finished because you haven't isolated the x. So you're going to isolate the x by subtracting 3 from both sides. So x equals negative 3 plus or minus the square root of 15. Once again, this is a lot faster, many times, than using the quadratic formula. Although the quadratic formula always works, so you can use that. All right, on 42, you made your square. That's y squared, so it's y times y is y squared. You had your minus 10y here, so you knew you needed a minus 5y and a minus 5y, which you get by going y minus 5 and y minus 5. And finally, you have negative 5 and negative 5, which is positive 25. Now you've got what you have, y squared minus 10y minus 15 equals 0, but you need this perfect square trinomial, which is y squared minus 10y plus 25, and then it's equal to some number. You get that by saying what plus negative 15, because that's what you have right now is negative 15. What plus negative 15 will equal 25? You can just add 15 to both sides. 25 and 15 is 40, so the number that you're looking for to create 25 is a 40, so you're going to add 40 to both sides. This is just to help you. Not everybody needs that step. So when you add 40 to both sides, you end up with the perfect square trinomial, y squared minus 10y, negative 15 and 40 is plus 25. There's your perfect square trinomial. If you add 40 to one side, you have to add it to the other, so 0 plus 40 is 40. If you factor y squared minus 10y plus 25, you get y minus 5 times y minus 5. There are your dimensions right there, equaling 40. Y minus 5 times y minus 5 can be written as the square of a binomial, y minus 5 squared. Then you're going to take the square root of that to get y minus 5. If you take the square root of the left side, you must do the same on the right, so square root of 40. which gives you plus or minus the square root of 40. Now, you're not isolated, your y is not isolated yet. You have y minus 5, so you're going to add 5 to both sides. So you end up with y equaling 5 plus or minus the square root of 40. Now, be careful because square root of 40 is not simplified completely. There's the perfect square 4 that divides into it. So square root of 4 times square root of 10 gives you the square root of 40. Square root of 4 is 2. So you have y equals 5 plus or minus 2 times the square root of 10, which is your final answer. And when you're solving the quadratic using completing the square. The last problem that we are going to work on is number 43, z squared plus 9z equals 1. Okay, on this one, z squared plus 9z equals 1, this is a little trickier because you're going to end up with some fractional amounts. Now, this one on the right is what you probably came up with. That's why I put it in here. Okay, so you probably said half of 9 is 4.5, did 4.5z, then went 4.5 times 4.5 and got 20.25. There's nothing wrong with this in that if I were grading it or free response, I would say all your processes were right. But this would not be the answer. Z equals negative 4.5 plus or minus the square root of 21.25. This would not be the answer on a multiple choice test. So let me take you through the process of what it would be. So you take half of 9. Well, half of 9 is 9 halves. So just 9 divided by 2. So it's going to be 9 halves. Put something in. Okay, so you have 9 halves here and 9 halves here because z times 9 halves is 9 halves z. And then 9 halves times z is 9 halves z. So 9 halves z and 9 halves z, let's go ahead and highlight this, will give you your 9z, okay, because it's going to be 18 halves, which will be 9. Then you have to multiply 9 halves times 9 halves. 9 times 9, numerator is 81. 2 times 2 is 4, so 81 fourths. So what you want is z squared plus 9z, and then you want your perfect trinomial, which is 81 fourths. And right now you have 1 here, okay? And right now you have your third term is 0. So you have to say, how do I get a third term of 81 fourths? Well, you take and put 0 here, say 0 plus 81 fourths gives me 81 fourths. Here it is right here. 0 plus what gives me 81 fourths? Well, 0 plus anything is that thing, so it's 81 fourths. And then you had to convert one whole. Let me see if I can fit this in a different color. 1 whole equals 4 fourths. So then you would have had 81 fourths plus 1, or 81 fourths plus 4 fourths, which is 85 fourths. You already know that z squared plus 9z plus 81 fourths is a perfect square trinomial, and you can write it as the square of a binomial, z plus 9 halves times z plus 9 halves, which gives you, written as a binomial, z plus 9 halves squared. And then you've got your 85 fourths. To get rid of the square, you're going to take the square root of both sides. So you end up with z plus 9 halves equals plus or minus the square root of 85 fourths. There's your square root of 85 fourths. You would subtract 9 halves from both sides, so you end up with z equaling negative 9 halves plus or minus the square root of 85 fourths. Now here's where you have to be careful. That's not the final answer. Square root of 85 fourths can be written square root of 85 over the square root of 4, because I saw that 4, so I knew, ooh, that's a perfect square. I might have to do some more simplification. So the square root of 85 can't be simplified further, but the square root of 4 can be to 2. So you end up with your final answer being z plus or minus, z equals negative 9 halves plus or minus the square root of 85 over 2.